All right, let's talk about the story of modern physics. We're going to take a journey from a universe that seems to run like a perfect, predictable clock, all the way to one that's governed by, well, cosmic chance. It's an absolutely incredible story. So here's the big question, right? Is the universe this predictable machine that just chugs along? Or is it all based on chance? For centuries, we thought we knew the answer. But then, a series of pretty shocking discoveries came along and turned our whole understanding of reality completely upside down. It all started with this one simple, elegant idea. Okay, so let's start at the beginning. Our story kicks off in this elegant and honestly pretty intuitive world of classical mechanics, a universe that, for all intents and purposes, ran like a perfect clock. And at the very heart of this clockwork universe was this really powerful idea from Isaac Newton. The thinking was, if you know the position, the momentum, and all the forces acting on an object, you can predict its future with like perfect certainty, no guesswork needed. This big idea, we call it determinism, basically suggested that the entire future of the universe was already set in stone. I mean, think about that. And because classical mechanics was so ridiculously successful at explaining things, it seemed like you could apply this mechanical view to literally everything. But you know how it goes. By the late 1800s, this perfect, neat little clockwork picture, well, it started to show some pretty serious cracks. Yeah, two major puzzles popped up that classical physics just couldn't solve. No way around it. And these weren't small problems. They were threatening the very foundation of everything we thought we knew. So first up, experiments were showing that the speed of light was constant for everyone. This totally contradicted Newton's laws. Think about it. It didn't matter how fast you're moving towards or away from a light source, you'd always measure its speed as the exact same number. It's just weird. So either all our measurements were wrong or Newton was. Something had to give. Okay, and then there was the second problem. Our best theories predicted that any hot object, what physicists call a black body, should be glowing with infinite energy, especially at high frequencies, like ultraviolet light. They called it the ultraviolet catastrophe for a reason. It would mean that if you turned on your oven, it should basically vaporize you instantly. And, well, since that clearly doesn't happen, yeah, physics was broken. Badly. So, to solve these massive puzzles with light speed and gravity, one physicist came along who didn't just, tweak the old rules. Nope, he threw them out completely. Albert Einstein was about to reimagine the entire universe. So what was Einstein's radical idea? Get this. He said gravity isn't a force pulling on things. Not at all. He said it's just what happens when mass and energy actually warp and bend the very fabric of space and time itself. And his equations show us something just profound. See, objects like planets, they aren't being pulled by the sun's gravity. Instead, they're just following the straightest possible path they can through a spacetime that's been curved by the sun's massive presence. It's like rolling a marble on a stretched rubber sheet with a bowling ball in the middle. The marble is just trying to go straight, but the curve dictates its path. And that was the revolution. Just like that, gravity wasn't a force anymore. It was geometry. It was the actual shape of the universe. Space, time, and gravity were all tangled up together in this single dynamic thing we now call space-time. Okay, but at the exact same time all this was happening, a whole other revolution was brewing. This one was all about explaining the mysteries of the very, very small. Remember that pesky blackbody problem? Right, so to solve that ultraviolet catastrophe, a physicist named Max Planck came up with this idea that even he thought was kind of crazy. What if energy wasn't a smooth, continuous flow? What if it came in tiny little indivisible packets he called quanta? It was almost a fudge factor just to make the math work. But it did. It fixed the infinite energy problem, and in the process, it accidentally gave birth to a whole new field of science, quantum mechanics. And here's where things get really weird. Unlike the old clockwork physics, quantum mechanics can't tell you for sure what will happen. It can only tell you the probabilities of different things happening. The state of any quantum system is described by something called a wave function, and that function basically holds all the possible outcomes and their chances. Certainty is out the window. This just leads to a totally strange new picture of reality. You know that classic image of an electron orbiting a nucleus like a tiny planet? Yeah, that's wrong. It's more like it exists as a cloud of probability. The brighter the area in the cloud, the more likely you are to find the electron there if you look. So the clockwork certainty of Newton, officially gone. It's been replaced by the fuzzy statistical chances of this new quantum world. And it gets even more fundamental. The Heisenberg uncertainty principle says that we can never, ever know both the exact position and the exact momentum of a particle at the same time. And this isn't because our instruments aren't good enough. No, it's a baked-in feature of the universe. The more precisely you try to pin down where something is, the less you know about where it's going. Certainty itself is just fundamentally impossible at this level. So now we're left with two incredible, game-changing theories that describe our universe. But here's the catch. They lead us to a really profound modern mystery. It's like we have two rule books. General relativity, that's the rules for the really big stuff. Planets, stars, galaxies, the smooth fabric of the cosmos. Then you have quantum mechanics, and that's the rule book for the tiny stuff. Atoms, particles, all that weird probabilistic action. And here is the big problem. These two great pillars of modern physics, they don't play nice together. They are fundamentally incompatible. I mean, general relativity describes reality as smooth and continuous. Quantum mechanics describes it as chunky and probabilistic. You try to use the mouth from one theory in the other's territory, say inside a black hole, and the whole thing just breaks. It gives you nonsense answers, like infinity. So, how do we fix that? How can we possibly unite the physics of the very large with the physics of the very small? This question, right here, is what drives so much of modern physics. It's the search for what some call a theory of everything, a single, unified framework that could finally describe all the forces of nature, from the Big Bang to black holes, from galaxies all the way down to the tiniest subatomic particle. The point is, the story of physics is not over, not by a long shot. Our very description of reality is still evolving, still being written. So, from that predictable clockwork machine to a universe built on a game of cosmic chance, this whole journey just shows us that the universe is far stranger and way more wonderful than we ever could have imagined.